To achieve optimal efficiency and reduce running costs when fitting a heat pump, it's essential to ensure that the system is correctly designed and installed. Two key components of a system design are the volume of water within the system and the potential need for hydraulic separation. While other considerations such as pipe sizing and more are important, this section specifically addresses volume and hydraulic separation. Heat pump manufacturers will specify the minimum free water volume required. What we mean by this is any water that is always available to the heat pump that is not closed off by things such as zone valves and thermostatic radiators. This allows the heat pump to freely circulate the minimum water volume as and when it requires. A sufficient volume helps to prevent the frequent cycling of a heat pump compressor. If the heat pump is cycling too frequently, it will have a negative impact on its efficiency and will increase running costs. When we mention cycling, we're referring to the same concept as a boiler cycling, meaning the heat pump compressor turns on and off excessively within a short period of time. The second reason for a minimum volume relates to the heat pump's defrost mode. This will affect the evaporator, the component which is filled with refrigerant and absorbs the heat energy from the air. When warmer air encounters the cold evaporator coil, moisture in that air condenses into water droplets on the evaporator's surface. If the temperature of the evaporator drops below 0 degrees C, these water droplets can freeze, leading to ice formation and a reduction in the usable surface area of the evaporator, leading to potential damage. To protect against this, the heat pump will automatically activate a defrost mode on certain occasions. This mode effectively melts the ice off. You may occasionally observe large volumes of what appears to be steam coming out from the front of the heat pump. There is no need for concern, as this is simply a sign that the unit is undergoing a routine defrost procedure. It can be beneficial for the installer to explain this to the customer on handover. As the heat pump completes its defrost cycle, it uses a small amount of energy from the water in the heating system. If the volume of system water was too low, not enough energy would be extracted to successfully complete the defrost cycle. To increase system volume, a volumizer can be installed on the heating return pipework. Moving on to the potential need to hydraulically separate a system and what this means. A simple explanation for hydraulic separation. It separates the flow around the heat pump from the property's heating circuit. We describe these as the primary and secondary circuits. The primary heating circuit refers to the pipework within a heating system that is directly connected to the heat pump, the flow and return pipe. The secondary heating circuit is all of the pipework and heat emitters, whether that be radiators or underfloor heating within the property. Why would we need to hydraulically separate the primary and secondary circuits within a heating system? Two main reasons. One, if the internal circulator within the heat pump isn't powerful enough to circulate the water around the entire system, we can hydraulically separate it, meaning it only has to circulate around the primary circuit. We would then add an additional pump or pumps on the secondary side, which would circulate around the heat emitters. This separation would allow both pumps to operate simultaneously without interfering with each other. This is typically used for larger or complex system types. Number two, the second reason is to maintain flow rates. It enables free circulation around the primary circuit and heat pump, regardless of varying flow rates on the secondary side. For example, a homeowner turning down all of the thermostatic radiator valves. Now we have a grasp on the significance of system volume and the potential need for hydraulic separation, how do we incorporate these into our system? As we mentioned earlier, if we only need to increase a system's volume, we can use a volumizer. A volumizer is essentially a vessel designed to contain water without any complicated internal components. It's used to increase the water volume of the heating system. Typically, it features one inlet and one outlet for connection, and it should be positioned on the return pipework of the heating circuit. Now, if we had a system needing an increased water volume along with the need for hydraulic separation, we could use something called a buffer. A buffer is essentially a vessel designed to contain water, increasing the water volume of the heating system, but it differs from a volumizer because it will hydraulically separate the primary and secondary heating circuits. Typically, it would feature 4 connections: a flow and return from the heat pump, as well as a flow and return to the secondary system. Buffers can be standalone or integrated into your hot water cylinder. Integrated buffers can be particularly beneficial in situations where space is limited. This brings us to the third option. If your system requires hydraulic separation, but already has the necessary system volume, you can opt for what is known as a low-loss header. A low-loss header is essentially the same as a buffer, but with a smaller capacity of water, and again, pre-plumbed cylinders with integrated low-loss headers are available. There has been a lot of information to digest here. Let's look back at what we have covered. We started with 2 important factors in system design: volume of free system water and the potential need for hydraulic separation. Correct volume is needed to reduce cycling and ensure an effective defrost operation. Hydraulic separation may be needed if the heat pump's internal circulator isn't powerful enough to overcome the system's resistance, or if the flow rates on the secondary side are likely to be variable. The 3 main methods of achieving both these requirements are: number 1, volumisers. These increase the water volume of a system but don't hydraulically separate the system. Number 2, buffers. These increase the water volume of a system and hydraulically separate the primary and the secondary circuits. And number 3, low loss header. These hydraulically separate the primary and secondary circuits but don't add significant volume to the system.